Yes, class. Yesterday we've started with the graphs portion. So some of the graphs were left to be covered. Let us complete that. And one question of relative velocity I have told you. That is also an important question which we have to discuss. So see what all graphs we had seen yesterday. The basics of graphs we had started. It's the pictorial representation of a function and we get a straight line graph. If both the coordinates x and y are directly proportional to each other. Here, one thing that was very important was that slope of the graph is very important. Slope of the graph means when you divide y and x, then that tan theta. How are we getting tan theta? See, if this is theta, and if I construct a triangle here, so tan theta would be perpendicular upon base. What is the perpendicular? Y. What is the base? X. So that's why we have tan theta as the slope. So positive slopes, if the angle is less than 90 degree, acute angle we are getting. If it is more than 90 degree and but less than 180 degree obtuse angle, then this is negative slope, and zero slope if there is no slope that is being formed. So you have your theta as 0 degree, slope will also be 0 degree, and tan theta will also be 0 degree. One more thing we have seen that increasing or decreasing type of slopes. That is depending upon the constant or variable slope. In a constant slope, see, the best way to find out whether it's a constant slope, increasing slope, decreasing slope is to take points on the axis of the graph, not the axis, on the line of the graph, and then draw a horizontal along the x-axis. Whatever is the angle being formed, that will give you an idea. See, if all the angles are equal in this case, this is a constant slope graph. If the angles are increasing, then we get increasing slope. And if the angle is decreasing, we get decreasing slope. Now, let us start one by one regarding the equations which we have studied in this chapter. So, linear equation means when y is directly proportional to x to the power 1. If y is proportional to the power x and the power of x is 1, we get a straight line graph. For example, from your linear equations, from your uniformly accelerated equations which you've studied, this v1 is equal to v is equal to u plus at. See, if we plot any graph between these two, all would be a straight line. Okay, yes, Zainab, I will show. I'll give you time, that time I'll show. Okay, Zainab. So this is a straight line graph in this case. Secondly, we have the quadratic equation. Quadratic equations are those equations which have y directly proportional to x square. Those are your quadratic equations. So one example only that could be said from our calculations of uniformly accelerated motion equations. S is equal to ut plus half at square, right? Where we cannot use v square minus u square because there v square is there. Here we require power of y as 1. X has to be 2, but y has to be 1. And lastly, we have inverse relation graphs. See, you have y is inversely proportional to x. Now, y is inversely proportional to x square also, y is inversely proportional to x cube also. And this can go up to y is inversely proportional to x to the power n in this manner. So basically what happens here, this will be a hyperbolic graph in every case. It's just that the graph would become steeper as we move down, as we go down. The graph would become steeper. This would become, if for the next one, it would be like this. For the next one, it would go like this, like this. So steeper it would become. That is the meaning of it. Not in this one, in this, the limitations are till here only. But when we talk about the steeper graph, this is how it becomes. Now you all can write down, and you all can write down from here. Done this part?
No, ma'am.
Fine class. Now see, if we go by the actual terms which were there in our uniformly accelerated motion equations, we had position, we had time. So there was a relation between if you get a position time graph, what all things you can predict. Now, C class, one thing I'll tell you that is very helpful for your graphical questions. If you divide two quantities, you get the slope. Okay? You get the slope of the graph. So whenever you have to get the slope of the graph, you divide those two quantities. And when you multiply, you get the area of the graph. Means if two quantities, if the third quantity, the final quantity that you are calculating, some final quantity that is present, that you have to calculate, you can divide and get the slope of the graph. For example, if I have two physical quantities, one is position, other is time. Now let's go by the first one. If I divide x by t, what is position divided by time? Yes, class, what is position divided by time? Distance divided by time is which quantity? Yes, Jobita. Position divided by time. Yes, Zainab, right. Speed. This is speed. This will give you the velocity. So position divided by time, if it is giving me velocity. So when I have to find out velocity, I'll divide these two, and this would be the slope of the graph. So I'll calculate the slope when I require velocity. Fine class. Now see, if you have velocity and time given, if I multiply velocity and time, I get acceleration. So in this case, the area of the graph would give me the acceleration. So this is how you will decide whether you have to calculate using division or multiplication. You will check the final quantity. Like velocity divided by time would give you acceleration, and velocity divided by multiplied to time, this gives the position. Not acceleration, this gives the position. That will be calculated through area. But when I divide these two, see, I have multiplied these two. So I am getting the third quantity using the area. And when I divide this, I'll get the slope of the graph, which is the acceleration. So you should be very clear. If you have velocity versus time graph, so are you going to calculate the acceleration or you are going to calculate the position? If you want the position, you can multiply the triangle, the area of the graph, you can calculate. If you want acceleration, you can just divide and get the slope. This is how you'll be calculating. Right now, let us focus on position versus time graph. So see, there are few cases which you have to remember. If time is 0 and position is 0, so the graph will start from the origin. And look, the slope of the graph at every point, this angle, if I choose, this angle I choose, it's a constant graph and it's positive, right? The slope is positive. Why slope? How, how can we get velocity from position time graph? We can only get velocity by the slope. So which type of slopes are possible? This is a positive slope. That's why our velocity is positive in such situation. So if you want the velocity to be positive, time to be 0, position to be 0, follow this. Now, suppose we want time to be 0, velocity has to be positive, but we don't want the position to be 0. We want the graph is starting from some position. The vehicle has covered some distance, the body has covered some distance. So in such case, what we'll do, instead of starting from origin, we'll start a point at a point X along the position axis. How this will help us see? Time is still 0 at this axis, and we are getting a value of position that is covered. This is the position that is covered by the body. And see, still we are getting a positive slope. Look, theta. Here also, theta. So this is a positive slope. So again, straight line graph that this will satisfy. Look at some more graphs. Suppose I want velocity to be negative and I have position time graph. So velocity negative means we have the negative slope, and negative slope is possible when theta is more than 90 degree and less than 180 degree. That is obtuse angle. So we'll start it from the origin, that is x equal to 0, time equal to 0, and this will be along this will be, instead of acute, this will be making obtuse angle. Again, this is straight line only because it is position time graph, so it will always be straight line only, and slope will give us the velocity. Lastly, suppose from here we want the position of the vehicle to be covered, some position to be covered. So instead of starting from origin, we will start from here, from the x-axis, that is x comma 0. That is position is there, time, this time is 0, what we require. And see, this is the position that is covered, and again it is making obtuse angle, and we get negative slope. So these conditions will be given to you in the question. You have to construct the graph of it. Start writing it. Any graph you have not understood, let me know. I'll explain it. See the last segment of the graph. When you have position time graph for uniformly accelerated motion, velocity will give you the slope according to tan theta. Now see, if the velocity is changing, see, slope will be variable and this time the graph will be curved. Here in all these cases, our velocity was constant. See, angles were the same. In every case, velocity was constant. What if the velocity is increasing or decreasing? So same thing. You will get the increasing graph. See, theta 1, theta 2, slope is increasing. So slope is increasing, curve is increasing. Angle is increasing, slope increases, velocity increases. Here, if you mark it theta 1 and look at theta 2, angle is decreasing, slope is decreasing, velocity is decreasing. This I'll tell you, just write this down first quickly. So that was all about position time graph. Now velocity time graph. So again, regarding velocity time graph also I have briefed you this. When you divide velocity by time, you get acceleration. When you multiply velocity and time, you get distance. So this will give you the slope which will come when you divide. And this can be calculated through the area. So slope of VT graph gives acceleration, area gives displacement. Now in uniform motion, if acceleration is 0, because we are now talking about the slope part. Look, and slope gives you acceleration. Velocity by time gives you acceleration. This is the slope. Now, if acceleration is 0, means 0 slope graph, it would be a straight line with velocity positive. Suppose velocity is negative, but acceleration is 0. So we'll draw the same thing below the axis. See, velocity here, it is above the axis. So this is positive. It is below the axis. So this is negative. Though the slope is 0 in both the cases. Here also the slope is 0. Here also the slope is 0. Because 0 degree is being made with the time axis. Right, class? See, if we want acceleration to be positive, not 0 this time, that means a positive slope. So we'll have angle theta that is formed, which is less than 90 degrees. So see, all these values of theta, these are seen. If we want acceleration to be negative, but with a velocity having some value, so velocity is having some value here, look, v comma 0, some value of velocity, and negative slope gives you negative acceleration. Fine, class? Look at one more, just one more. Time is 0 this time. Velocity is negative. Acceleration is positive, means acceleration part was positive before this also. But this time, velocity is negative. So what we'll do? The portion that we were drawing above the axis, this would be now below the axis. And since acceleration is positive, it means for positive slope, we have to make the theta less than 90 degree. So theta is also less than 90 degree. And it is starting below the origin, that is giving us some value of acceleration, velocity, which is negative. Fine, class, write it down. One last question, then we will see. See class, this graph, you have various segments, O to B, then B to C, then C to D, D to E, this point, and then E to F. Now, values of velocity, no, just the single value of velocity is given. This is 10 meter per second, and this is minus 10 meter per second. You have the time duration. You have to calculate the displacement in 10 seconds. Now, see, this is velocity versus time graph. If you multiply, that is, you get the area of the graph, that gives you displacement. So this can only be calculated through the area of the graph. So this is a trapezium. So trapezium's area, at least we can calculate, right? Area of the trapezium, and this is negative. So minus the area of triangle. Actually, we have to add all of them. But since it is displacement, and in displacement, we take the negative value also. We do not just take the magnitude. Distance is always taken as positive because it is just getting added. But displacement is negative. So this is trapezium, this is triangle. So this area minus this area. Fine. Area of a trapezium. How do we calculate the area of a trapezium? Half into the sum of parallel sides multiplied to the height. See, let me write down this. First part, this is displacements calculation. When you are calculating displacement, area of trapezium minus the area of the triangle which is formed. So this is half into sum of parallel sides. This is how much? 4 minus 2. This is 2. And this is how much? 6. So 2 plus 6. This would be 2 plus 6. Then height. Height is 10. This is already given. So multiply to the height. Minus half into base into height. What is the base? What is the height? See, base is 6 to 10. That is 4. And height is minus 10. So ultimately, even when you are adding it, this is actually addition of the area. So when you are writing half into base into height, this either here you can write it as 10 or here you can write it as minus. So this becomes 40. This is plus, this is minus 20. So 40 minus 20, this is 20 meters. Second part is distance. Okay, second part, the calculation of the second is distance. See, in distance, when you are calculating distance, it's just the difference that will arise is here this won't be taken as minus. Why? Because for distance, remember, whenever we are calculating, even if you're taking step back, we just add it, we never subtract. So here also this would be 40 plus 20, that would be equal to 60 meters. Fine. Now, look here. One thing before this, it is saying acceleration versus time graph. So for acceleration versus time graph, you need the values of acceleration. See here, what would be the acceleration? A1. 10 divided by 2. See, slope. Y-axis, that is 10 divided by x-axis. This is 5 meter per second square. This is 0 slope, straight away acceleration is 0 here. Third, this is same graph, but the velocity is decreasing. So here acceleration is negative, minus 5 meter per second square. What do we call this? This is retardation. We call this as retardation. Next, this is left. So this is also 10 divided by 2. So this acceleration 4, this is 3. This is 10 divided by 2, but minus 10. So this will become minus 5 meter per second square. And lastly, this is A5. This is minus 10, but acceleration is also negative. So minus would become plus 5 meter per second square. Now you have the values of acceleration. Now we have to draw this. So see, for acceleration versus time graph when you are calculating it. There is a maximum value of acceleration, which we know. One is 5 meter per second square. Other is minus 5 meter per second square. Now, in the initial 2 seconds, what is happening? In the initial 2 seconds, acceleration is having a constant value. This is a constant slope. Velocity was increasing class, but acceleration was constant slope. And we know how to plot a constant slope. So till 2, this would be this constant. This would be a constant graph. What is happening next? 2 to 4, it is 0. So acceleration 0 in 2 to 4. Fine. Then 4 to 6, what is happening? Acceleration is constant but negative. So if acceleration is constant but negative, so constant graph will be like this and negative. So we have drawn it below the axis. Next, what is happening between 6 to 8 seconds? Again, same, minus 5, same. Constant acceleration with negative. So this will be here till 8. And lastly, that was plus 5. Plus 5 and again constant slope. So this would be right. This is how the graph would look like. So this is this, both these graphs are same. It's just that this is the acceleration versus time graph for this velocity versus time. Write it down quickly, class. Any doubts if you have, let me know. This was the last question from the graphs part. How can you use S is equal to UT plus half AT square for any of these parts? Do you know the initial velocity? Do you know the time? Only acceleration's value for a particular segment you know. Displacement also we do not know. So initial velocity, these equations are not valid. Just go by these methods. Either divide for slope and multiply for area. See class, how will you solve this question? This is an important question which is left. Because here, see, you will be solving it the same way you are solving. You have solved all the equations of uniformly accelerated motions. You know velocity of car A is 10 meter per second, car B is 2 meter per second, and both are moving, but the separation between them is 100 meters. Now you have to calculate the time taken by A to cross B. See, VA, this is 10 meter per second. Fine. VAB and VB is 2 meter per second. So you will be using the concept of VAB now. You know what is VAB? Relative velocity of A minus relative velocity of B. That is the relative velocity of A with respect to B. So your VAB is 8 meter per second, not square, 8 meter per second. Fine class. And see, distance between both of them, relative distance between both of them. This is 100 meters, right? So what is velocity? Velocity is relative. Relative velocity is relative distance by time. So time would be relative distance by relative speed. So relative distance is 100, relative velocity is 8. This will be around 12.5 seconds. So the time duration to collide it, this would be 12.5 seconds. Fine. Write down the solution. That completes with the motion in a straight line. Now I'll be starting with vectors in the next class. We'll start with parallelogram law in the first class only. Derivation of parallelogram law and the questions. Write it. And please let me know whenever your vacations are starting. So we can have extra classes also on Sunday mornings at least. Okay, class. If completed, you all can start. Thank you so much. Any doubts, please let me know. Okay, Shaima. Thank you.